Oh, reducing and non-reducing carbohydrates. With that, when we're looking at the reducing and non-reducing, now I'm not exactly sure what the word, what it means by reducing. I'm not sure what's being reduced.
Mm-hmm.
But generally, if you're having, with the hexoses, if you're having a 1-to-1 bond, is that going to be non-reducing?
So the reducing end, if we look at basic sugar here, actually,
Okay.
yeah, let's go there. So, I don't know if I'm drawing this right.
Yes, Sam, trying to...
So,
Did you miss a bond in the middle there?
oxygen.
There it is, that makes sense.
Alright.
Okay, yeah.
So, your reducing end is when you have, it's like you have an anomeric carbon.
Okay.
So the reason why it's reducing is, let's say this ring splits back open.
Right.
This would be like our double bond here.
Okay.
If this were to react with something, it would probably attack the carbonyl, and this would be oxidized, because it's oxidized when we lose a bond to the oxygen.
Right, okay.
And so that means it would reduce something else. So this is capable of reducing things
Okay.
when it's open like this. Now obviously when it's here, it probably won't reduce a whole lot.
Because it does it become more of an electrophile? Is that why it
Yeah.
becomes reducing? Yeah.
Yeah, when it's electrophile, an electrophile is capable of being oxidized, so that means it's a reducing agent.
Right, okay.
So, but like when this gets, so when this attacks here, when this oxygen attacks our carbonyl,
Right.
this is going to be, well, your oxygen won't really change, but this hydrogen off here, something will be reduced.
Okay.
And then this carbon gets, I guess it doesn't even change because it has oxygen. Scratch that. But if this were to react with something else, it could then reduce it. Whereas this end here, since there's no anomeric carbon,
Okay.
or anomeric carbons in the bond, this is a non-reducing end.
So even though it has the hydroxyl, it still can't break that bond.
Yeah.
And do the same kind of chemistry.
Because the reason why this one can come back is the fact that this bond can go back to the oxygen.
Right.
And then, like,
Where the carbons
This could
aren't
kick back
likely
down.
to do that. They won't.
yeah, they're not going to split.
Unless you have like a super crazy pH. Yeah.
Exactly.
Okay.
But sometimes, like there's an example in the book where you have a disaccharide, I think it's 2 fructoses,
Okay.
and both anomeric carbons.
Okay, yeah, the 5-member rings looked a little different. Wait, where is the anomeric carbon on a 5-membered ring?
The anomeric carbon is the carbon that has 2 bonds. Oh, I think
Opacity, is that it?
anomeric carbons are carbons that have 2 bonds to oxygen. It's like that one's
The
anomeric.
the one that was the carbonyl.
Mhm.
Right, I gotcha.
So this one, since both these ends don't have anomeric carbons, they're both non-reducing ends.
So this is a non-reducing sugar.
Yeah, exactly.
That why sucrose is bad? Doesn't break down as easy?
I'm not sure what the chemistry, like what the implications in the body are for being reducing or non-reducing,
Right.
but just being able to identify that is probably what's important for this class.
That's interesting. It has a fructofuran and a glucopyran for sucrose.
Yeah,
I would have thought it'd be the other way around.
that is interesting. You don't see glucose in a...
Yeah, I didn't. I thought it was the other way around. That's why I.
Oh, no, your
looked at it.
fructo is furanosyl, so this is your fructo.
Oh, I get those mixed up.
And gluco.
P,
So fructo.
P means 5 to me, so I think.
Yeah. I just had to think
But it's
Furanose
5
5.
carbons. 5 carbons.
So that's really just being able to identify that, and if you can just, oh, both my anomeric carbons are here, then you know it's a non-reducing sugar. But most of them will be reducing.
Cool.